Right, component 3 task book. Question 6, neurotoxins and paralysis of muscles. We are given a graph with 3 action potentials on, and then a data table explaining what's happening to some ions. And pretty simple style of essay goes tell us how A, B and C work. What we're going to have to do is relate the effects of A, B and C to our normal action potential. So if I just draw a normal action potential on here, so normal action potential, there it is at resting potential, and then we get arrival of an action potential, we get depolarization, opening of sodium channels, sodium rushes in, and that's our action potential. Then we get closing of the sodium channels, opening of the potassium channels, potassium floods out, and that repolarizes the axon, and then we've got a slight overshoot here, refractory period, hyperpolarization, and then back to our resting potential where we've got all of our channels closed and our pump for sodium and potassium working. So sodium goes out, potassium in. So just to run through that again, normal action potential, resting potential, we've got a sodium potassium pump running, sodium pumped out, potassium pumped in, and because it's 3 sodium out, 2 potassium in, this means our resting potential is in minus territory, so minus 70. Arrival of the action potential, sodium channels open, sodium voltage gated channels, and sodium rushes in to the axon. That makes the inside less negative until it gets to a positive value of plus 40. Sodium channels close, then we're going to get repolarization, opening of our potassium channels. Potassium rushes out because it's been pumped in previously, and that restores our resting potential. Refractory period, then eventually our normal gates are closed and pump is working again. That's the normal action potential. If we look at, let's look at A. So let's look at A, and here's A. So A is this one here. So A starts the same, and we notice that our depolarization, our action potential, our depolarization is not quite as fast and not quite as big. So why did this depolarize? This was our sodium channels opening and sodium rushing in. So that would appear to be where the problem is. So we've got A. I'm not going to write this out in a nice flowing essay, but we're thinking of the different areas that you might do. So some problem blocking our sodium channels, and then so sodium can't flood in, only a small depolarization does not exceed, I can't smell, threshold. So this doesn't exceed the threshold for a full depolarization, and so we're going to get no action potential. Muscles won't work. Muscles won't work or contract. So that's A. Then we need to think about B. Where's B? B starts the same, and we notice it takes quite a long time. In fact, it even goes down a bit, so further negative. Then we get our depolarization, our action potential, and then it doesn't actually come down like normal. It kind of stays quite high, comes down eventually, no refractory period. So that's B. So B is personally a little bit more tricky to think about. So we do get an action potential. So we do get an action potential, but there's a delay. So sodium can't come in as quick, so Na enters less quickly. This repolarization seems to take too long. So repolarization is slow. Why might that be? We need to relate that to our knowledge. So how do we get a normal repolarization? Well, we did that by opening potassium channels and potassium moving out. So that's possibly where the problem lies. So blocked potassium channels prevents potassium flooding out, restoring our, prevents flooding out, restoring the negative charge inside. And so why is that a problem? Well, it takes too long and the impulse might not reach the muscles, the delay in the next impulse. So all of this, takes too long for an action potential. Delay in the next action potential. And so you can see that'll be a problem for muscles. And the last one, a scary data table. How are we going to work our way around this? So for neurotoxin C, we need to look at our 3 ions that we know about. So we know about sodium. So if we ignore completely our neurotoxin and just think about at rest, ion concentrations at rest, resting potential. Does this agree with resting potential? We pump sodium out, so there's more outside than inside. Yep. We pump potassium in, so there's more in than there is out. That makes sense. And calcium, well, that's pumped out of our presynaptic neuron, and so we've got more out than in. That makes sense. This is our normal situation after stimulation. So after stimulation, we'd expect those sodiums to have come flooded in. That's our first part of this curve. And we'd expect our potassium to have flooded out. So there they go. And we'd expect our calcium to have come in as well in our presynaptic knob. And that's happened. So we've got a slight change there. And so we look at the difference with the neurotoxin. Is there a difference with this neurotoxin? No, there isn't. Those numbers look broadly the same. Is there a problem with our potassium? No, there isn't. Those numbers look roughly the same. Is there a problem with our calcium? Ah, yes. Those numbers look different to each other. In fact, those numbers there look very similar to our original set of numbers. So those numbers there look very similar to our original numbers. And so this situation hasn't happened at all. So that's the problem that we're hoping that you're going to come up with. So neurotoxin C, does not affect the generation of the action potential. So no problem with sodium, no problem with potassium. It does something without calcium, so it blocks calcium channels, prevents calcium from entering the neuron. From entering the neuron. And then we can suggest what the problem then is, just our normal synapse procedure. So prevents vesicles, prevents vesicles containing neurotransmitter from fusing with the, I can't remember to write all this, fusing with the presynaptic membrane. We don't release neurotransmitter into the synapse. So essentially this prevents synaptic transmission, and so the muscle won't contract. So looking back on this essay, we go, right, well, it's a nice essay. We've got an answer for one of our neurotoxins doing something to the sodium channels, which I know about. We got something blocking the potassium channels, and we've got something talking about our calcium. So this is our knowledge in a new kind of situation. Nice essay.